recording, and it is recording from the right channel. Excellent. It's funny, I was talking to Iraj the other day. Iraj is going to teach you, I think, cisp360. He's starting to take over 400 and 430. I cannot remember which one. But anyway, he said he was starting to record his classes because people are not expecting it. How many of your other classes have like screen recording and everything on YouTube? No? Okay. It doesn't take me any extra work, but I think it is beneficial. I mean, in the worst case, it's just wasted bandwidth and storage on YouTube, which Google does not care, right? All right, so we'll go ahead and continue with basic syntax and focusing on just expressions and operators. I added a few more slides, but the first thing I want to do is to remind people that I have changed this quiz here. Last week, I did not set a deadline, like you have to get it done by a certain date. Today, I took a look at the participation. I took a look at how many people have even attempted it or have started an attempt, and the answer was not encouraging. Okay, let's just say that there are enough people who has not clicked on it yet that had me started to worry, because this stuff fades away. Okay, even if someone fully understands everything that I talk about in class, during class, if people do not practice it, unless you know C already, like you have done C programming for the past 5 years. Okay, even during class, people understand the concept. If you don't get any practice, you will start to that knowledge will start to fade away soon. So that's why I'm changing it to close on Thursday. So we have until Thursday. Should have been a Wednesday. Anyway, if it says Thursday, I'll keep it as Thursday. It will close on Thursday, September 18th. So it is this Thursday at 10:30 a.m.
And it will automatically take the highest grade as our thing.
Yes, it continuously would do that. It would continuously take the highest grade until that date.
Even if we already did it?
Yeah, you can redo it. There's no limitation of how many times you can reattempt it.
No, I mean if we did it before you made it mandatory.
Correct.
Okay.
Yeah, this does not change what you have done so far. It simply says no more attempts after that particular time. Okay. So you will have to remember to do this because the next one depends on it too. So the next one is more operators, which is also in a quiz form. It is unlimited attempt, and it has no due date, no closing date yet for more operators, but it cannot open until you get a 90% or better with the previous one. So that I'm trying to force people to do it, at least get a 90% before moving on to the next quiz.
So
yep.
That means 100 because I got 6 out of 7 of 85. So.
Right. Because of rounding, it won't work, right? You have to figure out which one is wrong. I think it tells you which one is wrong based on score. It may not tell you why you're wrong, but it tells you which one is wrong. So you have to figure out that one. Is it the first one? I think the one.
Yes, it's the first one.
Okay. I'm going to explain the first one because I think enough people are kind of bombed by the first one. Okay. Okay, this is the first question. The first question says, it gives you the instruction to do base conversion, but the bottom line is this question here. This is the question of this particular, this is the only question that I'm asking here. What is the largest power of 2 that is less than or equal to 85? I'm not asking for the exponent. I'm asking for the actual power of 2, the value of the power of 2. So in this case, it would be 64, not 6. 6 is the exponent, but the power of 2, the power of 2 that I refer to is the actual value that is a power of 2.
The result of
Right. It's not the exponent of the power of 2. So I think that should clear up most of the confusion. I think most people are just not getting this particular one. Yep.
I was going to say, but it says largest power rather than, why isn't it
Inverted?
worded? Why isn't it worded different? Because it says what's the largest power, so obviously when you do the math whatever, it comes out to 6 instead of 64.
Well, okay, that's the inherent ambiguity of English. because I'm asking for, okay, there should be parentheses around the power of 2, and I'm looking for the largest of them. Instead of grouping these two first, so I'm looking for the actual value that is a power of 2, and I'm looking for the largest one that is still less than or equal to that particular number. Yep.
I was just saying that like a comma, that like 2, 4, 16, 32, etc.
Examples.
Yeah.
Yep. Okay, that will be helpful. In fact, I can change it right now. Okay, where is it? Edit quiz. It's okay, it won't show you the answers. Such as 1, 2, 4, 8, 16, etc. There we go. Thank you. That's a good suggestion. Save. Changes. Now the text of the question is changed. Okay, so we're moving on to more operators. We finished talking about typecasting, coercion, and promotion already, if I remember correctly.
That's what we were starting on today.
Oh, we're starting? Okay, the other class has that topic done already, so we'll go back to this one here. Okay, so we were just starting with this one. At this point, casting is only happening to make integers, narrower or wider. Those are the only things that we are doing. Because the only types that we have talked about at this point in this class are the different types of integers. 8-bit integer versus 16-bit integer versus 32-bit integer, and so on. Okay? So this is all about, changing the width of how we represent integers. The word coercion in programming is a type of typecasting. In other words, we are changing the type. But in this case, the typecasting is implicit. In other words, you don't have to say a single thing. You don't have to write anything, and the program or the compiler automatically takes care of that. So let's take a look at some examples here. We have a sample program here. It has two different variables. The first variable is a 32-bit integer. We call that big int. The second variable is an 8-bit integer. We call that little int. This line here already has one coercion. The reason why this line has a coercion is because 0 as a constant is automatically of quote-unquote regular int type. Now on most platforms, if not all, an int just all by itself without any width specification is automatically either 16 or 32-bit wide. So that means the right-hand side of the equal operator or the assignment operator is already a 32-bit number. But the other side is an 8-bit number. So that means the two sides do not have the same width. Equality or assignment does not work unless you have the same width on both sides. So what the compiler does in this case is to do a coercion. It is looking at the destination, which is the left-hand side, and say, oh, we want to store something into an 8-bit integer, but what am I given with? A 32-bit integer. So what it does is it automatically do the conversion for you. In other words, instead of using 32 zeros to represent the value 0, it will say, oh, that's too much. I cannot use 32 zeros. I will use 8 zeros instead to represent the value 0. But it is still, in concept, a conversion. Okay? Even though it doesn't take any execution time, when your program is running, it is still, in terms of concept, a coercion. Yep?
Sorry, I might have missed it. Did you say that the right-hand side defaults to 32 bits?
No, an integer constant always defaults to 32-bit.
Regardless of the platform, like 64-bit Windows?
That depends on the int itself. But basically, whenever you specify 0, it is of type int. So depending on your platform, int can be 16-bit wide, can be 32-bit wide, can possibly be 64-bit wide. But I have not seen a platform where it is by default 8-bit wide. So that's why a coercion has to happen on this line.
And since we've made little n 8-bit, the 0 is being converted to 8 bits.
Correct. Now, what if you try to specify something that 8-bit cannot represent? What if you try to specify 16,000, which cannot be represented in 8 bits? Well, that would be nice. Except it does not. Go ahead. Nope. Oh, okay, I thought you had an answer. Well, it just does a truncation. That's what it does. It will look at a 16-bit representation of 16,000, and it will say, I'll just throw away the most significant 8 bits. Now we have 8 bits left. It will fit into an 8-bit integer. I'm done. So that's not really a nice thing to do, but it's going to do it. Okay, but the first thing you should say is to say, tag, I don't believe it. Show it to me. Prove it. Okay? Sorry, no drink in this classroom. You can save it until later. I'm not asking you to dump it. I wouldn't do it.
Sorry.
All right, so let's go ahead and test this and see, okay, but how do we check and make sure that we can see that this is actually what's happening? Let me close the other one first. And I'll go ahead and create a test1 folder here. And I'll just write the same program that I have talked about earlier. And let's make it a CPP, which is a C++ program. In this case, it really doesn't matter. I do need one include stdint.h. This is a header file that defines all of those different names for different widths of integers. So we do need that one header file. And then in here, I'm going to use int8_t, little int, use all lowercase, same as the note here. And what I'll do is to say little int gets a value of 16,000 and then return 0. That's all I'm going to do. Not a particularly useful program, but it should be enough to demonstrate the concept. So I'm going to exit the editor and use G++ to compile. And I'm just going to combine everything into one single line here. I'm creating an executable called test1. -G means I am including debug information. Otherwise, I cannot use a debugger for what I intended to do. And then I specify the input file as test1.cpp, which is our source file. So I'm rolling the compiling and the linking into one single step. And it does complain here that we have a overflow in implicit constant conversion, which is a coercion. This is good, okay? Because what it's saying is, overflow testing is automatic. That's not bad, okay? But when you look at the message itself, when you look carefully, it is not an error. It is a warning. Okay, I'm just going to highlight the portion that I want you to look at here. It is a warning, which means the program did compile and the linker did link into an executable. There is an executable called test1 here. Okay, so let's go ahead and see what happens when we, gdb test1, list the program, put a breakpoint on line 8, which is one line after the assignment itself, run the program to that point, and then print little int. Okay, that doesn't look like 16,000 to me. It's -128.
What's the /200 mean?
Sorry?
What's the /200 mean?
The /200 is the same value, but expressed in octal, base 8 number. All right. So here comes the question. How many people are going to read the messages from the compiler and realize the compiler is nagging? We should all be paying attention to all the warnings. Okay? So keep this in mind, okay? Because there will be at least half a class here that will continue to ignore warning messages. You cannot ignore error messages, because if you get an error message, it doesn't compile. There's nothing they can run, and your program is quote-unquote not working, not compiling at all. So you cannot ignore error messages. Warning messages are different. Warning messages are more like, the compiler is nagging at you. It's like, it's not gonna work. It's not gonna work. Okay, and some people look at it and go like, yeah. You don't know what I'm doing. I know what I'm doing. So I think the program is gonna work. I'm gonna ignore your warning. Okay, half of this class is gonna do that. Not only in this class, but in the next class and the class after that. Ignoring warnings. Okay, some of the warnings may seem trivial. It's like, oh, okay, it's no big deal. I think I know this is going to be okay. But not all of the warnings. So your job as a programmer is to make sure that you eliminate all of the warning messages. The trivial ones, there are always ways to get around it, to eliminate the error message, okay, or the warning message in this case. So do not ignore the warning messages. You have been warned. All right. Okay, so you might say that, oh, but this program is so obvious. Even I can see, with an 8-bit integer, it cannot represent anything more than three digits in decimal. So, okay, maybe that's not, obvious enough. Fine, I'll give you something that's more obvious. 127. Hey, 127 is the largest value you can represent using an 8-bit integer because it is 2 to the power of 7 minus 1. Okay, so it should work. Let's make sure that this works first, right? So we go back and we rerun, G++, no warning messages this time. Now, when you look at the same program, and if I just add one more line here, and I say, let's multiply little int to itself. Little int times little int. Okay? Now we should have a problem. Because 127 is already the largest positive value that you can store as an 8-bit number. If you square it, naturally it's not going to be within the range of values that you can represent. But do you think this is going to cause any problems? Well, let's try it, okay? Because the compiler now has to be very smart in order to give you a warning message. Because in this case, the compiler has to be smart enough to understand that between the line of little int gets 127 and the next line, nothing can happen, okay? In other words, this is 127, this is 127, in order for the compiler to be smart enough to give you a warning message. And it does not. It's not smart enough. Okay? But you run into a similar problem as the previous case. You're now trying to represent a value that cannot fit inside an 8-bit number anymore, and yet this time, because of the way I formulate the expression, there's no warning anymore. Okay? But the casting is done anyway. Okay, the casting is done in this particular case on this line. There's an implicit typecast or coercion here. There's no coercion in this case. The second line in this case has no coercion because it looks at little int as an 8-bit number, and it automatically says this multiplication is an 8-bit multiplication. Because now it's saying, okay, I have an 8-bit number on one side, I have an 8-bit number on the other side, it's just an 8-bit operation. And as an 8-bit operation, the entire right-hand side of the assignment operator is only 8-bit. The left-hand side is 8-bit, 8-bit, 8-bit assignment operator, no problem. And it would just do it without complaining about a single thing. Okay, so in this case, only you can save yourself from, a situation where you are storing a value that is too big to store in the smaller integer. Basically, you have to look at the possible value, the range of values that you want to store in this particular variable, and just make sure that you have enough bits to store that value. So are there any questions about this example? Yep.
We're writing a program though that loops a finite amount of time, and it's initially set to 8 bits. There's a chance that it will run past the typecast amount.
Mm-hmm.
So why not just default it to the largest typecast and eliminate the problem?
Well, but the argument applies to the largest type 2 because you can still run out. Even if it's a 64-bit number, you can still run out. So the solution is not to use the largest one. The solution is to analyze how you use your variable so that you understand, oh, okay, in this context, this variable can only go from this value to this value, and it will easily fit within an 8-bit, 16-bit, or 32-bit number. Because a 64-bit number can run out too. I mean, it can only represent up to a certain value, and there's always a chance to exceed that.
So you were saying 8-bit by 8-bit multiplication won't cause a problem for the compiler?
Correct, because the compiler is basically saying, okay, the left-hand side is 8-bit, the right-hand side is 8-bit, so this entire thing is just an 8-bit multiplication. And that's why it does not give you an error message or a warning.
So you mean like the ones and zeros will be multiplied, and that's why it won't get... Well, I don't understand how it would still say 8-bit after multiplying together.
That's because, when you have multiplication, the width of the result of a multiplication is dictated by the width of the values on its left-hand side and its right-hand side. So with an 8-bit by 8-bit multiplication, the result is just 8-bit. I understand what you're saying, because when you multiply an 8-bit number, the largest 8-bit number to the largest of the 8-bit number, you end up with a 16-bit number, or a number that can be represented only with 16-bit or more in terms of width. But as far as the compiler is concerned, it doesn't think that way. The compiler is looking at 8-bit times 8-bit, the result is 8-bit. And so it will only require the other side to be 8-bit to store the result.
But it'll give us an altered result, what the actual result is, right?
It will give you the truncated version of the result. In other words, it will do the multiplication, but out of the 16-bit actual product, it will truncate it. So the most significant 8 bits will be chopped off, and it will only keep the least significant 8 bits.
Okay.
All right, so that's the first type of typecasting. It is automatic. The second one here, that's also an implicit coercion. The coercion has to do with, one is a 32-bit in most platform integer, and this is an 8-bit integer. So the coercion is happening when we perform the addition, not when we perform the assignment. Because when we perform the addition, the compiler sees one side is, oh, this is only an 8-bit number, but as soon as it sees the 1 as a constant, it will see it as a 32-bit constant. So right at that time, the compiler will decide, oh, I have to bring the left-hand side to the same width as the right-hand side, and the coercion happens at that time. So little int will be what we call promoted to a 32-bit number before the addition happens. And then the result of the addition is going to be a 32-bit number, and that 32-bit number has no problem being stored in the 32-bit number. So the assignment operator is not what triggers the coercion. It is the addition operator that triggers the coercion. Are we doing okay so far with that concept? This one here also has a coercion. This one has a coercion not because of the addition operator, but because of the assignment operator. When you look at the addition operator and look at both sides of the addition operator, they are both 32-bit numbers. Big int is a 32-bit number. 1 is a constant, is a 32-bit number. Okay, I'm an addition operator. On my right-hand side, we have a 32-bit number. On my right-hand side, we have a 32-bit number. So I don't have a problem. I don't need to do any type of typecasting or coercion. But the result of the addition is a 32-bit number. So from the perspective of the assignment operator, it has a problem. Because one side, which is the right-hand side, specifies a 32-bit number, but the left-hand side, which is what you want to store into, is only specifying the space of an 8-bit number. So the coercion happens when we perform the assignment operator. It has to chop the 32-bit number into an 8-bit number, only keeping the least significant 8 bits in order to store into an 8-bit number. And this seems like a case where the compiler really should yell at you and say, oh, this is not good. Okay, you're trying to fit something that is much bigger into something that's small. Okay, let's see whether the compiler complains about it. So we'll continue to modify this program, and this time we have a 32-bit number, big int, and we'll just go ahead and say big int gets a particular value, okay, 16,000. and then we say little int equals big int, plus 1. Okay, it doesn't matter. And then we'll see whether the compiler complains about it. GDB, G++. And it does not. Because it is well within the ability of the compiler to quote-unquote automatically adjust for the width. Are there any questions about this part here? Now, there are what we call switches that you can pass to the compiler. Now, what kind of switches you can pass to G++ or GCC? They're about the same. The answer is many.
What is switch exactly? What do you mean by switch exactly?
Okay, I'm gonna look it up here. G++ switches. Okay, this is what we call a man page, which is an abbreviation of manual. G++ and GCC basically share the same manual, and all of these things that you can pass to it with a dash something, like we have already used dash G in this class. We have used dash O in this class. We have used dash C as well in this class. Some of these are used for controlling warning messages. So everything that starts with a dash uppercase W, not lowercase because it's case sensitive, dash uppercase W basically controls what type of thing the compiler will warn you about. Okay, and you can turn on certain things, you can turn off certain things too. So when you look up this page and just look for dash uppercase W here, you can see, okay, these are the defaults, but there's a whole bunch, warning options. There we go. So you can warn extra, warn all, warn address, warn aggregate return, warn array bounds, warn no attributes, blah, 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 and so on. One thing that really helps is to specify warn all, okay? Which means turn on everything, okay? If you can warn me about something, warn me about it. So this is one thing that later on in your other programming classes that you can explicitly turn on. With code blocks, you can still specify that. Okay, code blocks has a graphical user interface, but one of the options that you can specify to the compiler is how much warning you're going to get when you compile a program. And then for those of you who are saying, oh well, I don't even trust myself. Okay, when there's a warning, because I can completely ignore a warning, and just keep running the program. You can actually turn a warning message into an error message. So what used to be just a nagging is like, this is not going to work. You can turn it into an error message, and it stops the whole thing. Okay, so that's even a better option. I cannot remember, how to do it, but there's an option to do it. You can turn warnings into errors, so that way you cannot ignore it. Okay, because you cannot get past it when that happens. All right. Are there any questions about, how to use the compiler to give you the most amount of warnings and errors messages so that you don't have to fix the program later on?
Case 2 is just going to add a bunch of leading zeros to the little int to make it 32-bit.
Right. Well, kind of. That's a good question. The coercion on this, okay, when you convert a narrow integer into a wider integer, we pad the most significant bit to the left-hand side. So that means if the most significant bit was a 0, we pad zeros all the way through. But if the most significant bit of the 8-bit number is a 1, we pad 1s. Because it's a signed number, so if you keep padding zeros, you're changing the value of you're changing the value that the new integer is representing. So if it is ending with a 1, if the most significant bit was a 1, it's a negative value. So you have to pad with 1s in order to preserve the value that your 32-bit number is representing. You don't have to worry about it. It will do the right thing to preserve the value when you are promoting. Okay, so here is the actual promotion. It's not coercion. This one is called promotion. It is not implicit. This one is explicit. So you're basically explicitly saying, oh, let's use this type of integer instead of the default type of integer. So we'll take a look at the original expression here. In the original expression, the x and y are both 32-bit integers. So you can say, well, even though the intermediate result may exceed 32-bit, since we're dividing it with by another 32-bit number, the result is guaranteed to be a 32-bit number. But that's not good enough. Okay, let me just repeat what I said in a slightly different way. So based on your analysis, based on your analysis of the range of values of x and the range of values for y, you know that it is guaranteed as an overall expression, the quotient of the division is guaranteed to fit in 32 bits. Okay, so based on your analysis, you know the final result is 32-bit. So we should not have a problem storing this back into a 32-bit number. But the problem is you're performing the multiplication first. So when you're performing the multiplication first, the product of the multiplication is a 32-bit number in this case. The reason why it's a 32-bit number is because x is 32-bit wide, x is 32-bit wide. The left-hand side and the right-hand side of the multiplication operator are both 32-bit wide. So that means the multiplication is a 32-bit multiplication, which also means the product is going to be 32-bit wide. Right there, you get a truncation possibility. So by the time you get to the division, the problem has already occurred. You already lost, some of the most significant digits. So that's why, this is dangerous, because it seems like, everything's going to be okay, but it's not. In order to make this, really safe, even if you know the overall result has to be within 32-bit wide, you need to do it something like this. In other words, what you're going to do is only to force one side of the multiplication, force one of the values to a 64-bit number, and that's all you need to do. Because once you force one side to a 64-bit number, the multiplication operator will automatically say, oh, I got one 64-bit number on one side, one 32-bit number on the other side. I better coerce the other side to also 64-bit number in order to perform a 64-bit multiplication. A 64-bit multiplication always gives you a 64-bit product. Okay? So what do you do with a 64-bit product in this case? So because of this promotion, this is coerced to 64-bit wide. Now because both sides are 64-bit wide, the entire product is going to be 64-bit wide. This is 64-bit wide, this is 32-bit. So the division operator will basically say, oh, one side is 64-bit wide, the other side is 32-bit wide. I'll do a coercion to bring this 32-bit wide back to 64-bit wide, so they'll be the same. So now we have a 64-bit division. This entire thing is a 64-bit division. It will give you a 64-bit result as the quotient. Yep.
Will it also promote the left-hand side?
No, because this is an assignment operator. You cannot promote the left-hand side when you have an assignment operator. So in this case, the left-hand side is 64-bit wide. The right-hand side is 64-bit wide. The left-hand side is only 32-bit wide. So when you perform the assignment operation, it will truncate it. So you're going to lose the most significant 32-bit. But if you did an analysis and make sure the quotient is always going to be 32-bit wide, then it will still be okay. But the important part is the intermediate calculation. The product needs to be 64-bit before you do the division. So are there any questions about this particular case, why the promotion is going to be helpful in this case? Yep.
Yes, right. So you put the N64 just in case the X and Y values exceed 32-bit amount.
Say again?
You put the 64 in there just in case when the multiplication and division does happen, it exceeds
Correct.
32.
In case the product is going to exceed the representation of a 32-bit number, this will make sure that the product is properly represented, and that the division is going to be a 64-bit division as well. So the quotient may or may not fit within 64-bit. So you have to analyze the calculation, make sure the result will fit back into a 32-bit number. But this is required when the intermediate product can already exceed 32-bit wide. Is that okay?
Yeah, it's fine.
Okay, great. So that's basically all the entire slide for typecasting. Now this is just the beginning of typecasting in this class. Later on we'll do typecasting for structures and pointers, and that's going to get a little bit more difficult, a little bit more hairy when we get to that. In your next class, cisp360, which is object-oriented programming, coercion and promotion takes on completely new meanings. Okay, so I'm not going to scare you guys with all the stuff that you will have to deal with in the next class. For the time being, all we want to do is to control the width of integer results. That's all that we are doing here. Right, so let's move on to the next topic. And there's a way to switch to the next one here, which is ternary and unary operators. Funny names. Okay, so for the most part, except for negation, which is kind of like an obvious thing, like negative x is the negation of x, we use binary operators. Multiplication is binary, addition is binary, subtraction is binary. Now in this case, when I say binary, I don't mean that they're using base 2. All I mean is the operator requires 2 values. When you're adding, you need one value here, one value here, and it gives you the sum of those 2 numbers. When you have division, you need 2 numbers. You need the dividend and you need a divisor, and so on. So that's what I mean by binary in this limited context. But in C and C++, there are interesting ternary. There's only one ternary operator that I know of, but there are several unary operators, that are really useful in C and C++. Okay. And the 3 here basically means, is tern, T-E-R-N, means 3. And then means 1, so that's why they have these funny names. So we'll start with the simple one first. The really simple one is called a post-increment decrement operator. Post-increment I got it flipped, unfortunately. The name is correct, but the content is not entirely correct. Let me fix it first, and then we'll come back to this note. I just caught myself. Okay, the term post-increment means the incrementing is afterwards, but what I really want to illustrate here is the post-increment. Mixing this one up with this one here. I have 2 ways to fix it. I'm just trying to find out which way is the easier way to do it. This is what I'm doing. I'm changing this to pre-increment and then use the other one for post-increment. Apologize for this. So this is plus x. Okay. I'm going to start with this part here. Okay, so we'll start with the pre-increment decrement operator. Now the word pre is referring to when is the change actually happening. Is it happening before or after? Pre-increment or pre-decrement means it is happening quote unquote before. The question is before what, right? So let's go ahead and take a look at one expression first. This is an expression, it's a pre-increment of x. So that means that x is increased by 1 first, and then what happens? And then the value of the expression is the current value of x. Okay? So it is technically the same thing as this other expression here. Because remember, the equality operator returns a value. It returns the value of what is being used to update the variable on the left-hand side. You guys do kind of remember that? And plus plus x is basically functionally, this operator here, this expression, is functionally the same as this expression here. You can consider it a shorthand, if you will. Okay? And then someone's going to say, attack, prove it. Okay? I'm not convinced, you made a mistake earlier, and I'm not convinced that this is the way it's supposed to be. Okay? Well, you can test it. Okay? So let's go ahead and write another program to test this one here. We'll call this test 2, and we'll also make this a very simple, program. And this time, I'm not going to use the width specification, just because it's not really needed in this case. So I will have, let's say, 2 variables, x and y. We'll initialize x to some non-zero value. We'll pick, say, 17. And then we'll say y equals to plus plus x. And then return 0. So the question now is, what is the value of y after the assignment operator on y? It should be 18, exactly. Because it is the same thing as, remember what I said a bit earlier? Okay, this is the same as y is equal to x equals to x plus 1, close. Okay? Attack, that looks awfully confusing. We have 2 assignment operators in one single line. Well, that's okay. You have to look at it one step at a time. First thing you look is this one here. This is the innermost parentheses, so it is always evaluated first. So in this case, because x started off with a value of 17, x plus 1 equals to 18. Okay? So what do we do with 18? We use 18 to update x itself. Now the value of an assignment operator is the value that is used to update the left-hand side. Since we used 18 as a value to update x itself, that means this entire expression, remember assignment is an operator in C++, this entire expression is just returning a value of 18. So the next question is, what are we doing with that value of 18? Well, this entire thing is the right-hand side of this assignment operator. So that means this 18 is used to update y. So y should end up with a value of 18 in this case. Is that okay so far? So we want to see whether that really is the case or not. Go ahead.
First you have x equals to 17. Then the line after that, you have it x equals to 18 and y equals to 8.
Okay, this is what I'll do. I'm going to do this one step at a time. First thing, we resolve what x is. At that point, x is 17. So the entire expression becomes 18. Is that okay?
That goes into x, right?
That goes into x.
So plus plus x means storing.
It means add 1 to x first, and then whatever x is after the increment becomes the value of that expression, becomes the expression of plus plus x.
What if it was just 1 plus?
Say again?
What if it was just 1 plus?
What if it is 1 plus?
1 plus x instead of plus plus x.
1 plus x does not change the value of x.
Okay.
It calculates the sum of 1 and x. And you have to use that result right away, otherwise it disappears. Plus plus x, on the other hand, does 2 things. The first one is to increment the value of x. So the variable gets changed right away. And the second thing it does is to give you the value of the expression, which is the new value of x. Yep.
Is there a way to increment it more than just one?
Yes, we have another operator that can get it done. So just hold on to that thought. We'll get to it. Right. So we'll test this program. The whole point is to test this program and see if y ends up with a value of 18. Right. So we'll go ahead and do a g++ -o test2-g so that we include debug information. So GDB would work. Test2.cpp, and then use GDB to test the program. GDB test2, list the program, figure out where we want to stop. Let's stop on line 6. So we'll put a breakpoint on line 6, run the program, and now we have stopped. Okay, line 5 has executed already. We are now stopping at the beginning of line 6. So the first thing we can do is to verify x now has a value of 17, which is what you would expect. Okay, this is not mysterious at all. And now we can single step. We can single step on line 6, and now we can say, okay, y should have a value of 18 now. And what do you think is the value of x at this point? Also 18, right? Because we actually changed the value of x to 18 first, and then we use that 18 to update the value of y. So both x and y should have a value of 18 at this point. So I will print x first, has a value of 18. I'll print y next. It also has a value of 18. Okay? So that's how you can convince yourself of a particular understanding of a certain concept, is to design an experiment. Make it as simple as possible. Don't make it fancy. Make it as simple as possible. Run the program, use a debugger to help you track down the values of the variables, and verify your understanding of the concept is in fact correct. Yep.
How do we keep the value of x at 17? So let's say that 17 has to remain a constant, like if there were 17 people in this class.
Mm-hmm. Well, then you just say y equals x plus 1. Because when you evaluate x plus 1, it just grabs the current value of x, add 1 to it to make an intermediate result of 18. But the value of x as a variable does not get changed. Okay, you don't want to change. Your question is, what if you do not want to change the value of x and still want y to be 1 more than the value of x? Is that your question? Then you can just say y equals x plus 1. Because in that case, you're calculating the sum of x and 1, but that sum doesn't get stored into x, it only gets stored into y. And that was another hand. Yep, you're next.
Sure.
Yep, go ahead.
Why 1 though? Why can't it be 2? Where did the 1 come from?
Well, that's how the operator is defined. Plus 1 increments by 1. There are ways to increment by other values. We'll talk about that next. Yep.
And this is called a pre-increment operator because just pluses are in front of the x. Is that
Right. Because we're adding before we refer to the value of x. The other one refers to the value of x and perform the addition after. Okay. So, are there any questions about this particular program? Nope. Okay. So we'll go ahead and look at the next one. Okay, the next one is called post increment. Post increment, the word post means after. Okay, so after what? Relative to what? I'm adding 1 to x, but after what? Okay, well, let's take a look. This is actually a very interesting operator because if you look at the name of the programming language, which is C++, C++ is the perfect demonstration of what is post increment. Okay, that's how a post increment operator looks like. So we'll take a look at this. In this case, the post increment operator is a little bit harder to explain because it is kind of like, well, why would we want to do something like that? Okay, let's see what it does. a variable is still incremented or decremented, but the value of the operator itself is the value of the variable that is being incremented prior to the actual increment or decrement. Okay, I know that's kind of difficult to explain. So that means, let's say x started off with a value of 6. Okay, x plus plus as an expression will do two things. One, it will basically say the value of the expression is the old value of x, which is 6. Okay, but it will do another thing, which is what we call a side effect. The side effect is to increment the value of x. In other words, as an expression, it returns 6, but it will also change the value of x to 7. Is that okay? Sort of? Okay. So we'll go ahead and demonstrate that concept. First thing is the equivalent form. The expression x plus plus, which is really simple, is actually the same thing as this expression here. What? This is an expression? What is it? Well, it is using a comma as an operator. When you use a comma as a separator, all it's really doing is to separate this into two individual operations. This is one expression, this is another expression, but the result of the value of the overall expression is the value of x minus 1. In other words, we have distinctly two things to do. One thing, the first thing we do is we say, oh, x gets x plus 1. We're incrementing x by 1, which is also the same thing as plus plus x. But that does not serve as the value of the expression. What serves as the value of the expression is the value of x minus 1 after the first operation here. Is that okay? I know it looks confusing, but is it still okay? Okay.
What's the point of getting the value of the expression to plus 1 and then going back to the, I don't understand.
We'll get to that later. At this point, we don't really have a whole lot of use for that, but later on we'll definitely start to see the application of the post increment operator. Okay, so what we'll do is we'll run an experiment first, just to confirm our understanding of all these concepts. So once again, we have x and y. X gets a particular value to begin with, let's say 12, and then this time let's use decrement. Okay, so we'll use y gets x minus minus as a post decrement operator, just to make it a little bit different from the first one. So we want to find out or predict the values of each variable after each line, and then we'll go to the debugger and verify, oh, okay, that's exactly what it's doing. Okay. The first line, no problem here. So after this executes, x will end up with a value of 12, and since we did not initialize the value of y can be anything after this line executes. After the second line executes, things get a little bit interesting, because x will get decremented. It's a post-decrement operator after all. But y is going to end up with the value of x prior to the decrement. In other words, y will get the value of 12, the value of x before the actual decrement. So that's my prediction. Okay, this is what is supposed to happen based on my understanding of post-decrement. Okay. So when you study, you don't just say, oh, okay, this is what text says, we'll just remember that. You run experiments like these, okay, just to make sure that you understand the concept correctly. Besides, this is also a good chance for you guys, especially if you're new to command line interface and you want to learn it, okay, just to do it a few times, and before long, it won't take you much time, just to get in and out of the editor, run the compiler, and run it in the debugger. Okay, so we'll do a G++ -O test3 -G to include debug information, test3.cpp, and then we'll use GDB, the debugger, to test this program. List the program, put a breakpoint on line 5, and then run the program. This time I put a breakpoint one line earlier than last time, because I want to illustrate something. I want to illustrate if you do not initialize x has a initial value of 0, but y has some kind of awkward initial value. In other words, if you have local variables in the subroutine, there's no guarantee of the initial value of those variables. Do not make any assumptions. Okay. In this case, x seems to have, oh, that's 0. That's a good initial value. Don't count on it. Okay. If it is a local variable, do not count on any initial value. And here's the row sheet for today. The third column is for today.
And so we couldn't do x equals x minus minus, right?
You can. If you do a x equals x minus minus, then you're not changing the value of x. That's a good question. We'll test it next, but we'll run through this program first, and then we'll test your suggestion. So we'll run the program. Oops, no, I don't want to rerun it from the beginning. We are already on line 5. So we single step line 5, and then we say, okay, x has a value of 12. That's good. We expect it. Now we are on line 6. Okay. So we want to single step line 6, and now we want to see what is the value of y, because according to my understanding, y should have a value of 12, because y gets the initial value of x before the decrement. Y has a value of 12. What about x? Well, x is affected by the decrement operation, so x should be now 1 less than what it used to be. So print x. X now has a value of 11. Okay. Are there any questions about test 3, which is this particular program? No questions? Okay. So now let's get back to your question here. We'll call that test 4. So that's a very wrong extension. That's a very good suggestion. So the question is, if we have, let's say, x equals to 4 here, okay, what is x equals to x minus minus? Okay, so if we work this through based on our understanding of the operators, x equals 4, I don't think we need to explain that line, but the second line is kind of confusing because on the right-hand side it says x minus minus, which does two things, right? As an expression, it gives you the value of x before the decrement, which is 4. And then as a side effect, it changes the value of x to 3. That's the right-hand side of the assignment operator. But nonetheless, the value of the entire right-hand side gives you a value of 4. So what do you do with that value of 4? You put it back into x, right? So that means this line of code should not do a single thing to x. It will decrement it, and it will get it back to the original value. Okay. So once again, I'm claiming this is what the program should do, but does the program actually do that? Well, we have to test it. So we'll do a g++-o test4-g test4.cpp, and then gdb test4, list the program, and this time I'll be a little bit lazier than last time. I'll just put a breakpoint on line 6, run the program, print the value of x just to make sure it is 4, and then single step, print the value of x again, it is still 4. For a very brief moment, it was 3, and then it got back into 4. Okay, are there any questions about all of these examples of pre-decrement and pre-increment and post-increment and post-decrement? And I agree with you guys, the post-operation or post-increment and post-decrement doesn't seem to make any sense, okay? I just want to add something or subtract something from this variable. Why do I care about the value prior to the increment or the decrement? It doesn't seem to make any sense at all. Well, at this point of this programming class, it doesn't make any sense. But when we start to get into loops, okay, then it starts to make sense, because this is one way to make really, shorthand loop constructs compared to without this construct. Okay, it's not necessary. There are tons of programming languages out there without the plus operator, pre or post, either way. So, and they still manage to survive and do everything that we need to do. But C++, which is based on C, has these operators so that we can make really kind of more efficient use of resources, of expressions. Okay, it makes things look kind of more cryptic, but at the same time, they are quote unquote more efficient. So I will answer that question of why do we have post operations later? Okay, because at this point I don't have anything to show you why it is useful. All right. So if there are no questions about pre and post increment and decrement, we'll move on to the ternary operator. The ternary operator is kind of weird. It looks like this in the general form. C in this case is an entire expression. I'm just using C as a placeholder for condition. TV is an entire expression. I'm using TV as an abbreviation or a placeholder for true value. And then we have FB here for false value. Okay? And we have two symbols, two punctuations here for the ternary operator because there are three things to specify. The first one is a question mark, and the second one is a colon. So that's the general format of a ternary expression. So we'll move on and talk about what it actually does. Well, as an expression, what it does is it will first evaluate C or the condition. If C as a condition is non-zero, then it will use TV as the result of the value of the entire expression. If C turns out to be 0, which is false, then it will evaluate FV and use that as the value of the entire expression. In other words, this is a conditional statement in an expression. We are packing an entire conditional statement into a single expression using the ternary operator.
What does the question mark mean? Oh, it's if. That's the.
Yeah, basically, if you want to look at these as words, this is more like then, and this is more like else. And the if is kind of implicit before the C, expression of C. Okay? Now this operator may sound really strange, but it does exist in other contexts also. In most spreadsheet applications, such as Microsoft Excel and LibreOffice Calc, without any scripting, this is the only way to perform any type of conditional operation. Now, who would want to do something conditional in a spreadsheet? I would, all the time. Okay, you can use it to change how something is formatted. You can use it to change how something is calculated, and it is really powerful because this is the one way you can make your spreadsheet do something depending on a condition. Okay, in some cases I want to do the calculation this way. In other conditions I want to calculate it the other way. And then someone may complain and say, "Oh, but that only gives you two choices." What if there are 3 or 4 branches that you have to specify? Well, no. Remember, I said no if statements, right? Well, that's why I'm sliding down here. Okay, you can nest these things. In other words, the true expression itself, a true value expression, can be its own ternary expression. The false value can be its own ternary ternary expression. So this way you can use nesting, and then in one single expression, you can now have as many branches as you want. It is a whole bunch of conditional statements rolled into a single expression. So in the slide here, I also explain here, what are the possible results from this entire expression? Well, the entire expression can either return C, D, F, or G. But what about A, B, and E? Well, those are conditions. They help to steer to the right expression as the result, but they cannot return as a part of the result. So expression A, expression B, and expression E are basically quote-unquote hidden. They can only be there to help you steer to the right result, but they do not appear as a part of the result.
So the entire BCD is the true value of A, and the entire EFG is the entire false value of A.
That is correct. Yep. So, and also here I basically explicitly state C is going to be the value of the entire expression if A is non-zero and B is non-zero. D is the entire result when A is non-zero but B is 0. E is the result when A is 0. Oops, excuse me, take it back. F is the result when A is 0 and E is non-zero. And then G is the result when both A and E are both zeros. So it's a conditional statement in an expression. So here comes the question of, why do we bother with something like this? I mean, why don't we just use a conditional statement like a normal programmer? And why do we do something that cryptic? Well, the reason why ternary expressions can be cryptic is because of formatting. Okay, because we tend to write an expression in a linear way without using line breaks, right? You just put it all into the same line. That makes it hard to read. If you use the right formatting, ternary operators, if you use parentheses and also use line breaks, a ternary expression can still be easy to read. Because C as a programming language, C++, C and C++, consider line break and tab as a single space. So that means you can put in as many line breaks as you want in an expression, and it doesn't change the meaning of the expression. All right. Here comes the next question. Well, okay, given that this can be not so cryptic to understand, but still, I still don't get it. Why do we want to have conditional stuff in an expression? Why don't we just use conditional statements? I know conditional statements has to be in C and C++. So why do we bother with putting everything conditional into a single expression?
It's faster.
Well, it is. It depends on what you're doing. It's not necessarily a whole lot faster, but one thing you can do with this is the entire expression can be a parameter, can be used as a parameter to a function call. So instead of using a conditional statement and replicate 2 copies of a function call, you can now have one single function call, and then inside a particular parameter, you put in a ternary operator. So a part of the function call is conditional. What you pass to the subroutine is conditional, but the other parts is not conditional. It's the same regardless of the condition. So it gives you, a lot of options of how to do things. Are there any questions about the ternary operator? No questions? Okay, I'm going to give you a preview of your next quiz. I think I made all the corrections correctly here. So I'm going to save and return to course with all the corrections. And then I will show you, kind of the questions that you will see with the last link here, more operators. Oh, great, someone has already attempted it. Good job. But I'm going to show you a preview. Okay, so this is kind of a preview of what kind of question you get. Assuming x has a value of 42 initially, what is the value of x after the following expression is evaluated? Oh, wait. I forgot one thing, sorry. Not quite ready for that yet, because I forgot one more slide. Compound assignment operators, that's it. Okay. So if you consider a general expression like this, okay, x equals x something y, okay, so that's something which is OP here, which stands for operator, can be addition, subtraction, division, multiplication, modulus, which is which is getting the remainder of something, can be a bitwise operator, can be bitwise AND, bitwise OR, and bitwise exclusive OR. Okay, so OP can be one of those many different operators. So what I'm saying is this can basically you can use a shorthand. So the shorthand is if you have an expression like this, x gets x plus 1, so plus becomes the operator, you can turn it into what we call a compound assignment. In other words, we are combining the addition and the assignment into one single symbol here. X plus equal 1 is the same thing as x gets x plus 1. They mean exactly the same thing. It's just a shorthand. So what about division? Well, x equals to x divided by y is x divide equal y. Okay, they do exactly the same thing. One is just a shorthand of the other one. the question is, why do we want to, understand this? I mean, why do we need to know this? Okay, this is not really that bad. I mean, this is shorter, but do I really have to know this? Well, the answer is, are you going to write every single line of code in your future, or do you think you might need to read the programs of other people? If you need to read the programs of other people, you need to understand this, because you will encounter notations like this from other programmers. Right? So that's the whole thing. So as I said, this operator, which is the same thing over here, can be one of the many operators that we have talked about so far. Can be addition, subtraction, division, multiplication, bitwise AND, bitwise OR, and bitwise exclusive OR. There's one more operator that I have to explain in 3 minutes, but that's more than enough time to explain it.
Can I ask a quick question?
Go ahead.
So that operator right there just means you put you just move basically x to the other side of the equal sign.
And then the operator to separate x and the other side.
Okay.
Right? Okay, the last one is the modulus operator. This is the one. This is an easy slide. That's the entire slide. Like here. Okay. The modulus operator is basically the remainder operator, if you will. X percent. No, I should use the same notation here. V is a value. Percent B is basically the same thing as the remainder of V divided by B. So normally in a slash, which is a division operator, we get a quotient. In this case, we don't get a quotient. We get the remainder of the division. Is that okay? Let me test you. Let me test whether you guys understand division or not. Most people will say, division, come on, it's elementary school stuff. Of course I understand all this stuff. So I'm going to give you guys a little ungraded quiz here. We'll start with something that you are familiar with. 17 divided by 7. What is the remainder?
3.
Okay, because it's 2, which is 14, and the remainder is 3. Easy schmeezy. What about this one here? Let's say 1 divided by 5. Some of you are smiling because you saw that in P300 already. Okay, 1 divided by 5 has a quotient of what? 0. And the remainder of 1. Okay? Does it make sense to you? Okay. Because sometimes when people see the dividend being less than the divisor, they just kind of go like, oh, wait, this doesn't look right to me. Well, it doesn't look right because most of the time, that's not how we encounter the division operation. Most of the time, the dividend is quite a bit bigger than the divisor, so that we have some non-zero quotient and a remainder. But it is entirely possible someone can say, oh, what is 1 divided by 5? Tell me what the remainder is. Well, it's just 1. There's nothing strange about it. Okay. Is that okay so far? So in your test, you will encounter stuff like this. I just want to give you a quick preview of your assignment, because now we have covered all the operators. You do have everything that you need in order to answer the questions. Doesn't mean that it will be quick. Okay, it might take you a little bit of time to deal with this here. Okay, so here's the question. What is x plus equal to, and then in parentheses x plus equal to 1. Okay, I use the parentheses to clearly indicate which one goes first. Okay, which one to evaluate first. You don't have to give me the answer. I'm just giving you an idea of what type of question you'll be asked. It will be asked here. There are only 5 questions. This is the second one. Assume x has a value of 78 to begin with. What is the value of the following expression as a whole? So in other words, you look at this entire thing. What is the value? Okay, it looks complicated because it exercises almost all of the things that we talked about today. When you approach something like this, do it step by step. Okay, just don't look at it and go like, oh, this is way too much, I can't process it. Okay, just break it down to the smallest steps and then make sure that you start with the right one. Okay, the innermost parentheses has to be evaluated first. Just follow that order. And then we have another one here. Okay, this one is combining bitwise NOT operator with typecasting. So x is 63 prior to the following expression. So I'm asking you, what is this thing here? And once again, I put in extra parentheses so that we emphasize this is a typecast of x, and then I use the result of the typecast of x as a part of the other operation. I'm not going to tell you what this operator is. You're supposed to know it. I mean, you can look it up. Here's another one. Assuming x has a value of 78 prior to the following expression, what is the overall value of this expression? I don't need to know what is the value of x afterwards. I need to know the overall value of the entire expression using commas. So you have to go read the section on commas to understand how to get this one through. And here's a good one. It's a combination of bitwise operation again and the compound assignment operator. So assuming x starts off with the value of 34, what is x caret equal to 26? So this one is going to involve base conversion. There are ways to do this without base conversion, but I think using base conversion first is going to be easier. All right. Are there any questions about this particular exercise? And once again, you can do it as many times as you want. Okay, you make one attempt and you go like, oh, I only got 60%. Well, do it again. Okay, you can do it again until you get 100%, and even after that, you can just say, oh, I still want to do it because there are, I think, 40 test cases with each question. So it will take you a long time to encounter all of the possible cases. You just have to do it until you get a good feel and say, okay, I think I know how to do it now. Okay, so the whole point is for you guys to do it as an exercise. I mean, you can easily look it up and say, oh, okay, I just want to go to a certain website and evaluate the expression to get the answer. But that defeats the whole purpose of me putting up a quiz like that. All right. So if there are no questions, I'll see you guys on Wednesday. Thank you.